Emma, and who else can I see on the screen? Zimasa. Okay, if I pronounce your name wrong, guys, please let me know. Okay, you guys are in charge of reminding me at the beginning of lessons to record the meetings, okay? All right, guys, any questions about just the structure of the year, how things are going to work, etc., etc.? Shout out, put up your hands. Okay. All right, I just want to quickly run through the class list and just say yes. Okay. I've got a list of names, but let me just double check. If you're here, okay, Emma.
Yes, sir.
Zamasa.
Yes, sir.
Cassia, please tell me if I mispronounce your name, anyone?
Yeah.
Cassia, is she here?
Sir, you can call me Melanie. Yes.
Sorry?
Sir. Yes, sir. You can call me Melanie.
Melanie. Okay, let me just make a note of that. Okay, whatever you prefer, guys, it's up to you. Melanie. Okay, Ella.
Yes, sir.
Shamini.
Yes, sir.
Caitlin.
Yes, sir.
Mishka.
Yes, sir.
Divya.
Yes, sir.
Keliswe. Have I pronounced it correctly? Keliswe.
Stelisiwe, sir.
Kelisiwe. Is that right?
Yes, sir.
Kelisiwe. Okay, thank you. Tanulwetu.
Yes, sir. Would you call me Tando?
Okay, cool. Amokalang.
Yes, sir, but you can call me Amo.
Okay. Rory-san.
Yes, sir.
Ilhan. Is it Ilhan? Musa. Not yet. Okay. Jolie.
Yes, sir.
Marang.
Yes, sir.
Is it Pia or Pia?
So it's Pia.
Pia, thank you. Piladi.
Yes, sir.
And is it Inay?
Yes, sir.
Okay. Is there anybody else that's here that I didn't call out? All right. Okay, guys. These lessons are always a bit like talking into empty space. Okay, I just want to, it's optional now if you want to stay or if you want to go. Did I send you, I'm just going to ask one person at a time. Tando, do you know if I sent you guys, did I send you the memos for these exercises?
I don't think so, sir. I didn't see them.
Okay, I'll check if I haven't, and if I have, I will send you the memos, the work memos. I've got an answer book. Okay, so I'll send you those at the end of this lesson. But in the meantime, what I'm going to do is I'm going to work through just a few randomly picked sums from this section, okay? So if you want to go now, you're welcome to go. If you prefer working on your own, it's absolutely fine. I promise you, I'm not going to be offended. But if you'd rather go work on the textbook exercises on page 106, okay, 105 and 106, you're welcome to go do that on your own, in your own time. Okay, but I'm going to work through some of those between now and the end of the lesson. Okay, so as I say, you're free to go. Okay, right, but I'm going to work through some of that stuff. If you do have your textbook, okay, we're on page 105 and 106. Okay, as I say, I'm going to go through some of that stuff now. I just did a lesson with my anti-matric APs where I talked for 15 minutes and they didn't tell me I hadn't shared my screen. So if that ever happens, please tell me. Right, and I want the visualizer. Okay. Shamini, can you see that the white blank page?
Sir, I don't see it.
Don't you? Okay. Wait, let me just check. Share. I haven't shared properly, that's why. Okay, come on. Share. Okay, here it comes. Okay, let's try again. Now.
Yes, sir. No, I see it.
Hallelujah. All right. So guys, we are on. So we're using this textbook over here. We also did send you a PDF, Finance and Modeling. This is a section which previous years have struggled with initially. So if you are finding it a bit tricky, it's absolutely fine. What I'll Okay, let's just go through some things. I realized something this morning that I thought you had done and you haven't done. Okay, and I'm going to have to give you a little crash course in that, I think. Okay. So we're going to do exercise 1. Okay, and I'm just going to do the following questions with you. Okay, number 10. Okay, 12. Let's do 16, 17, 18, 19, and 20. We probably won't get through much more than that. Okay, so 10, 12, 16, 17, 18, 19. Just making a note for myself, and 20. I'll write the questions down. Okay, and you're going to need your calculators, guys. Okay, so question 10. Please, often as well, what happens, guys, is I'm looking at my paper and I don't see that I've kind of taken the, you can't see anything anymore because I've moved the paper. Please yell at me if that happens. Okay, right. And in this question it says determine the recursive formula for each of the following sequences and hence find the 15th term in each case. And in question 10 you've got 1, -4, okay, -9, -14. Okay, and they want the recursive and sorry, let me move this over a bit, otherwise you just see my hand. The recursive and the 15th term. Caitlin, you are the handwriting monitor. Okay, when it gets terrible, which it often does, you have to shout at me and remind me, please. Okay, right. So, guys, the difference between a recursive sequence. Okay, in core maths, you're never going to work with recursive sequences. You're only going to work with explicit sequences or general formulas. Explicit sequences, you can generate the value of a term depending on its position. Okay, and the position we call, the notation we use for that is n. So if I said to you, term n is equal to 4n plus 7, okay, that means I can straight away go find out the value of the term in position 50, which would be 4 times 50 plus 7, which would be whatever, 207. That is an example of an explicit sequence, okay, because it generates the value of a term based on its position in the sequence. So here the positions are n is 1, 2, 3, 4. Okay, that's the position in the sequence over there. This thing over here is referred to as T1 is 1, T2, the term in position 2 is 4, the term in position 3 is -9, the term in position 4 is -14. So explicit sequences or general formula do that. Recursive formula or difference equations. A difference equation is just another word, okay, for a recursive formula. A first difference equation depends on, so the thing is with recursive formula, okay, you can't, they depend on the value of the term before. So a lot of computer programming is done using recursive formulas because the computer can do that quickly, okay? So you need the value of the term before, or sometimes 2 terms before, okay, in order to generate the sequence. Okay, so in order to get term 4, you need the value of term 3, or else in order to, that's called a first difference equation, where you just need the 1. Okay, but if you needed term 2 and term 3 to get term 4, that's called a second order difference equation. So here they want a recursive formula. Okay, and there are 2 main types. Sequences where you're just adding a fixed amount, which are called arithmetic, and ones where you're timesing, which are called geometric. Okay, so first of all, I would always, as your first step, go look for that. Are you adding or subtracting something? So in this first question over here, I'm just got a class list in front of me. I'm going to randomly pick names. Rory Sang, are you there?
Yes, sir.
Okay, so to get from one, and if you ever get anything wrong, don't stress anyone. Okay, to get from one term to the next, okay, are you adding or subtracting an amount, a fixed amount?
Subtracting, sir.
Good. How much are you subtracting?
5.
Okay, you're subtracting 5, so you're minusing 5 to get from one term to the next. Okay, so to write this out as a recursive formula, okay, you can say term. There are 2 ways you can write it. You can say term n. I think we must stick to 1. Okay, is equal to. So the term in some position. Okay, what do you have to do to get from term 1 to term 2? You have to take away 5, right? So term n, okay, is equal to the term before that. And the term before term n, you write as term n minus 1. Okay, in other words, term 3, the term before term 3 is n 3 minus 1, which is term 2, right? That's the term before. So the term in position n is the term before minus 5. Okay, that's a recursive sequence because it's generating the value of a term, but you've got to know the term before in order to get that. Okay, you could also write it, or you could say the term in position n plus 1, and if you've got a term in position n plus 1, then the term before, okay, would be term n. Does that make sense, Rory-san? So term 3 would be, the term before would be term 2. Okay, so in other words, term 3 would be term 2 minus 5. Okay, so term n plus 1 would be equal to term n minus 5. You can use either of those two things as your answer. So you could say term n is equal to term n minus 5, or you could say term n plus 1 is equal to, sorry, term n is equal to term n minus 1 minus 5, or the term in position n plus 1 is equal to the term in position n minus 5. Okay, and just check, okay, does it make sense? But now, if I just gave you that orange information, Rory saying, would that be enough? Say I didn't tell you the sequence. I just gave you that, one of those. Let's just work with this one. If I just gave you that, term n is term n minus 1 minus 5, could you go write down the sequence?
No, sir.
What's the problem?
You need to know what term 1 is.
Yes, so you need to write the value of the first term. So guys, if you just wrote that, you'd lose a mark. Okay, you have to say term 1 is equal to, what is term 1? It's 1. Now with both of those bits of information, okay, you've got enough information to generate the sequence. Okay, so the first term, okay, so term 1 is 1. So in other words, term 2 is going to be 1 minus 5, which is minus 4. Term 3 is going to be equal to minus 4 minus 5, which is minus 9. Are there any questions about that? You don't have to write that whole thing. The textbook writes n is an element of natural numbers every single time. I will not penalize you if you don't write that. It's always assumed in modeling and in sequencing that n is a natural number. You don't have to explicitly write that down. But you do have to write down this, and you have to write down that. Or you can use that language over there. Okay, any questions, guys? I can't see hands when I'm working on the screen, so you're going to have to shout out. And I'll assume silence is consent. Okay, so that's number 10. Right, then we're going on to number 12. Okay. Right, and in question 12, okay, the question is, you've got 1.5, 1 3/4, okay, 2, 2 1/4, and they want a recursive. Ah, guys, I forgot to do something. Okay, I'll go back to, I'm going to do some, I'll get the 15th term for this one. Okay, right, so in this one over here, 1.5, 1 3/4, 2, 2 1/4. Right, the first thing you have to check is, are you adding or subtracting a fixed amount? Sometimes it's easier to see if you write it as an improper fraction. So you've got 3/2, okay, and this is going to be 4 times 1 is 4 plus 3 is 7/4. Am I right? Okay. So you're going to be adding a quarter. Am I right? Yeah. It's actually not easy in this case. To get from 1.5 to 1 3/4, that's 1 2/4 plus a quarter is 1 3/4, plus a quarter is 2, plus a quarter is 2 1/4. So you're adding a quarter. Okay. To get from one, you can check on your calculator, guys. To get from one term to the next, you're adding a quarter. Okay. Right. So now, okay. Tell me, please, Piladi, are you there? Oh, has she gone? Pia, are you there? Anyone there? Okay.
Well,
Pia, are you there?
Said.
Who am I talking to?
You're talking to Pia.
All right, Pia. So how can I write this as a recursive sequence, do you think? If I started with term, let's say I've got started with term n. What's a term? What do you do to have to get from one term to the next?
You add a quarter.
Okay, so the term in some position is equal to the term before, which is, in this case, if that's term n, what's the term before, the notation for the term before?
N minus 1.
Good. Remember, that's a subscript there, guys. So it's term n minus 1, and what do you have to do? Add a quarter. So that is your recursive formula. I'll call the first order difference equation because it depends on one term before. Do you get full marks for that? Pia? If you just wrote that, would you get full marks?
No, sir.
What else do you have to write?
You have to write the value of term 1.
Good. So term 1 is equal to 1.5. Okay. Are we happy with that? Right. Now, the question says, guys, go find the value of the 15th term. I didn't do it for the last one. You can go do that yourself. Right. So to go find the value, use your calculator. So with recursive sequence, use a calculator to find the value of a term. So this is what you're going to, okay. What you have to do is you have to put the value of the first term in your memory. Okay. So the first term in this case is 1.5. Okay. So you're going to go 1.5 equals, right? Okay. Then you're going to clear your screen. Don't worry, it's still there. Okay. Your calculator saves whatever comes after the equal sign. Now, to each term, you want to add a quarter. So now you're going to go answer, okay, plus a quarter. So you can go plus a quarter, okay, and then you're going to press equals. Now I basically use my fingers to count. Okay, so term 2 is 7/4, which is 1 3/4. So that's working. The next one should be 2, if I'm right. So now I'm on term 2. So term 3 is 2. Term 4 is 9/4, which is 2 1/4. Now I've got to count up to 15, right? So I'm on term 4. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and I go all over there, and you should get to 5. Let me check the answer book if I'm right. Yep, I am. Okay, so you get term 15 is equal to 5. Okay. Any questions about that one, anyone? Okay. Right. Okay. I want to quickly jump, okay, to the more difficult ones. Okay. And some, just because we're going to run out of time. Okay. So I'm going to go to question 19. And what the mistake I think I've made in these lessons is that we did this later on in the year with other grades. It was just a lot, and you guys, I don't think, had done simultaneous equations. Have you done simultaneous equations in middle 5? Okay, so let me just help you with this a little bit. Okay, so let's have a look at 19. Question 19, and you've got, you can do these by inspection a little bit, but I'm going to just show you quickly. 2, 6, I am recording it, so if you've got to rush off, okay, I know you've got social responsibility. I think it's just a video you have to watch. Okay, so you can watch it later, or you can come back and watch this. All right. Does anyone have any clue how we go about getting a recursive sequence for this? So your first thing would be, are you adding a fixed amount? So you're not adding 4, you're not adding 4. Okay, so that's not working. Okay. Are you timesing by a fixed number? Well, if I times by 3, times by 3, times by 3, that doesn't work. Okay. So adding is not working, multiplying is not working. Okay, and so it's going to have to be a combination of both. Normally, in a question like this, we say to you, given that Tn is of the form, okay, A Tn minus 1 plus B. Okay, normally we tell you that. The sequence is of a form. What does that mean? It means the term is equal to a number times the term before plus a different number. Okay, that's what that means over there. So your objective now, so if it's not an arithmetic where you're adding or a geometric where you're timesing, okay, in that case, okay, it will be a combination of both of those two things. Okay, so there are two ways you can approach this. Okay, the one way is to do this. Okay, is what we use, something called simultaneous equations. Okay, right. Okay, in order to, so our objective now is we want to go find A and B. Okay, so in this particular example, term 1 is equal to 2. Okay, term 2 is equal to 6. Term 3 is equal to 14. Okay, if you can just do it by inspection, which you could with this one quite easily, okay, it's fine. So you could just look at it and say, am I timesing and adding? What am I timesing and adding? Well, I'm timesing 2. 2 times 2 is 2. Okay, plus 2 is 6, so that works. 6 times 2 is 12, plus 2 is 14. 14 times 2 is 28, plus 2 is 30. Okay, so there you could do it by inspection. So straight away, you could just write, to get from one term to the next, here, this is what your answer is going to be. Term n is equal to, well, what do I do to each term? I times it by 2. 2 times the term before, plus 2. That's going to be your answer, okay, by inspection. 2 times 2 is 4, plus 2 is 6. Okay, this means go times by 2 and add 2. 6 times 2 is 12, plus 2 is 14. 14 times 2 is 28. Okay, so that's working, okay? But often we're going to make it so that it's really difficult to do it by inspection. Okay, and in that case, we have to use something called simultaneous equations. As I say, I'm recording this. If you need to go, you can go. Okay, so how do I do that with simultaneous equations? Well, okay, I know that term 2, okay, is equal to something using this logic here. Okay, so we know that a term in this sequence is generated by timesing the term before by something and adding something. That's what that language means. So term 2 would be A times the term before, which is term 1, okay, plus B. Okay, right. Likewise, the term in position 3 would be A times the term before, which is term 2, okay, plus B. Okay, so in this particular example, what is the value of term 2? Term 2 is equal to 6, right? So we're going to go say 6 is equal to A, and what's the value of term 1? Term 1 is equal to 2, right? So 6 is going to be A times 2 plus B. In other words, 6 is equal to 2A plus B. Okay, right. If I go work with term 3 and term 2, okay, term 3 is equal to 14, right? So 14 is equal to some number which we called A times the term before, which is 6, okay, times term 2, okay, which is 6. So it's A times 6 plus B. In other words, 14 is equal to 6A plus B. Okay. Now I've got two equations with two letters. Now when I've got two different equations with two letters, okay, and you're asked to solve them, it's something that we call a simultaneous equation. And the easiest way to do a simultaneous equation is to get one letter on its own from one of the equations. Get one letter on its own from one of the equations. Okay, so let's say to get A on its own is going to be a mission, because you're going to have 2A is equal to 6 minus B, and if you divide by 2, you get a fraction. Okay, so you always want to avoid fractions. It doesn't matter which letter you get on its own, and it doesn't matter which equation that you use. Okay, so it's very easy to get B on its own over here. So from equation 1, I write equation with, this is naming the equation. So when I put a circle around it, means the name of that equation is equation 1, and that is the name of that equation is equation 2. It helps because you can refer to those equations without writing the whole thing down. So if I isolate a letter from equation 1, it's very easy to get B on its own, and you get 6, move that across, minus 2A is equal to B. So that's still equation 1, just written in a different form. Okay, that equation are the same thing, just written in a different way. Once you've got one letter, so this says get one letter on its own from one of the equations. Once I've got a letter on its own from one equation, I must substitute that value of B into the other equation. So you sub, the equation that we haven't used is equation 2. So if I call this equation 2, I'm going to sub B is equal to 6 minus 2A into equation 2. What that means, wherever I see a B, I replace it with 6 minus 2A. So I get 14 is equal to 6A, okay, plus, now I've got to change this B over here. I'm subbing this value of B is equal to 6 minus 2A into this equation. So I get 14 is equal to 6A. You had 14 is equal to 6A plus B, 6A plus B. But now we're replacing, okay, the B, okay, with 6 minus 2A. So it's going to be 14 is 6A plus B, so 14 is equal to 6A plus 6 minus 2A. Okay, so if I go solve this equation now, 14 minus 6 is 8. 6A minus 2A is 4A. Divide both sides by 4, and I get A is equal to 2. So the steps were to using simultaneous equations, okay, get one letter on its own, okay, sub it into the other equation, solve for that letter. I'm not finished though, because I've got to find B. And the easiest way to find B is to substitute back into, you can either substitute back into 1 or into equation 2. Just to show you, if I put A is equal to 2 into this one, I get 14 is equal to 6 times 2, which is 12 plus B. So 14 is 12 plus b, move that across, you get b is equal to 2. The easiest is normally to substitute it into the isolated form of the equation that you manipulated. So in this case, I'm going to sub into 1. Okay, and I get 6 minus 2a is equal to b, but I know that a is 2, so I get 6 minus 2 times 2 is equal to b. So 6 minus 4 is b, so b is equal to 2. Okay, right, so now I've got a is 2 and b is 2. The question was, a question like this is worth about 8 or 9 marks if it's okay. Now the question says to you, the question said they'll go write this down as a recursive sequence. Okay, so we go back to this form over here. I said term n, okay, so your final answer is term n is equal to something times term n minus 1. We know a is 2. So instead of a, we're going to write 2 times term n minus 1 plus b, which is also 2. So there's your final answer. You've just got to write one thing down, and that's the value of the first term. And the value of the first term is equal to 2. Okay, so there, guys, is your answer. It's quite a bit of work. Right, I know that you can go to social responsibility. What I'm going to do, okay, is I'm going to do one more of these sums. Okay, I'm going to finish off this sum and then do one more that I'm recording. You can go watch the recording later. I will send you the memos as well. Okay, so you're welcome to go. You're also welcome to stay if you're going to watch the social responsibility video later. Okay, the question also said, is anyone still there, by the way?
Yes, sir.
Yes, sir.
Okay,
Yes,
so if you
sir.
want to go, you can go. I'll talk to myself. Okay, who is still there? Give me a name, one person. I'll just talk to myself in case you leave. Okay, so now, okay, the question said, go find the value of term 15. Those people that are there, did you sort of get what I just explained?
Yes, sir.
Yes, sir.
Okay, so now they're going to
sorry,
want to, yeah,
So when
questions,
you
anyone?
like a question like this, you have to work it out like a simultaneous equation, like always.
No, you could do it by inspection. So a question like this, you could quite easily I would have just written the answer down because I can see I'm timesing by 2 and I'm adding 2. You get full marks if you just wrote the answer down. The problem is this, okay, I'm not a very nice person, so what I'll often do is I'll make the formula something like term n is equal to a third times term n minus 1 plus 7. And to spot that, to recognize that, okay, is going to be really, really difficult to do it by inspection. And if you can't do it by inspection, okay, then you're going to have to use this method. Okay, there is another method you can use. People tend to forget that method. Okay, they showed you, I think I might have shown you another method in the video. Okay, I can't remember. Did I do with the one with differences? So there is another method I could show you. Okay, I'll quickly show you it again. Okay, where the sequence was, what was the sequence again? 2, let me write it here. 2, 6, I don't usually use as much, so let me just check I don't make any mistakes. 2, 6, 14, 30. Okay, and then you look at the differences there. The difference between 2 and 6 is 4. The difference between 6 and 14 is 8. The difference between 14 and 30 is 16. Then I say to myself, so this is a formula, works for sequences of this format, a, t, n minus 4, where you're timesing a number and then adding a number, right? So this is an alternate method, okay? Then what you do is you say, what am I timesing? Are you timesing by a fixed number to get, you look at your differences. You look at your row of differences and you say, am I multiplying by a number? Well, I'm multiplying by 2. And if you're multiplying that by a number, then this number over here will be the same as that number there. Okay? So now we know A, so we know that this is going to be 2 times the term before plus something. 2 times term n minus 1. So you can use this method if you want to, plus something. Okay? And then you can just do it by inspection. So if you said, okay, what's 2 times 2? It's 4. What I have to add, it's 2. Because you know you're timesing by 2. 6 times 2 is 12. What I have to add, it's 14. 14 times 2 is 28. What I have to add, it's 30. Okay? So then you can just see by inspection, okay, that term n is term t, 2t n minus 1 plus 2. Okay, so that's another way you can use it. If you prefer that method, you're welcome to use it. Okay, but at some point you are going to have to use simultaneous in different things. Okay, right. Just quickly, okay, so we had term n is 2t n minus 1 plus 2. and we've got term 1 is equal to 2. Okay, and I want you to use your calculator to find the value of the 15th term. So what you do in your calculator, remember, you enter the first term on your calculator. So you're going to go 2 equals, and then you clear your screen. Okay. Now you have to use your answer button. So now you're going to say that number is, so you're going to go 2, that number there, times your first term. So instead of your first term, you're going to write answer. So you're going to have 2 times answer plus 2 equals. And check if it's working. Term 2 is 6. It seems to be working. The next one is 14. And that's term 3. 30 is term 4. So it's working, right? So now I'm up to term 4, so now I've got to count. Okay, so term 4 is 30 equals term 5, term 6, term 7, term 8, term 9, term 10, term 11, term 12, term 13, term 14, term 15. Okay, and I get term 15 is equal to 65,534. Okay, that's the value of term 15. Am I right? What question was this? Question, what number was this one?
19, sir.
19. Yep, I'm right. Okay. Right, so I'm going to quickly do 20. I understand if you have to go, you can come watch the video later. The video will be on Teams. Okay. In our class channel. Right. So I'm going to quickly do, if you want to stay, you're welcome to. I'm going to quickly do 20. Okay. So question 20. Okay, so you're welcome to use either method. Okay. Sorry, my phone's ringing. Right, so question 20 says, okay. So first, always try inspection. So say you got 8, 15. This one's pretty easy to see as well. 29, 57. Right. Is anybody there that wants to try this by inspection? Okay. So your first thing you're going to do is you're going to say, I'm just going to talk because we don't have time. Okay, plus 7. Are you adding 7? No, that doesn't work. Are you timesing? No, that's not working. So it's not arithmetic, it's not geometric, it must be a combination of both. As I say, normally we'll tell you it's of the form a number times the term before plus another number. Right. Okay. Does anyone think they can see that by inspection? It's pretty easy to see by inspection. What are you timesing and then minusing to get from one term to the next? Anyone, any ideas? Okay.
So
Yeah.
isn't it times 2 minus 1?
Good. Who is that?
Ine, sir.
Okay, Ine, you did right. Okay. So Ine, if you see it, if you just write the answer down, good for you. Okay. So term n is equal to, so you're going to say 2 times the term before, 2 times the term before, minus 1. So there's your formula. Term n is equal to 2 times the term before, minus 1. Okay? Check if it's working. 8 times 2 is 16, minus 1 is 15. 15 times 2 is 30, minus 1 is 29. 29 times 2 is 58, minus 1 is 57. Dead right. If you can see it by inspection, do it by inspection. And then you'd have to write term 1 is equal to 8. Full marks if you wrote that down. Okay. I'm going to show you the other methods because tomorrow I think I'll actually give you a class 1 that's kind of like where you can't really use inspection. Okay. But if you spot it by inspection, use it. You'll get full marks. I promise you that now. Okay. So if I said to you this, okay, if we did, let's use it the method we just did with the differences. So what do you do if you want to, if you know you've got something of this form, okay, probably the quickest way, okay, is to just do this. Okay, so you say, what's the difference between the two terms? Okay, so the difference between 8 and 15 is 7. Is this going to work? The difference between is between 15 and 29 is 14. The difference between 29 and 57 is 28. Okay, so you find the differences between the two terms. Then you say, what am I timesing by? Is there a fixed number I'm timesing by to get from one term to the next? And in both cases, we're timesing by 2. You might want to use this method. Maybe it's easier than simultaneous. Okay, right? So I'm timesing by 2. Whatever number you're timesing by, that's going to be A. Okay, so in other words, in my formula, I'm going to have term n is equal to 2 times the term before okay, plus something else. So that's what we know so far, and we know term 1 is 8. So now you're just going to figure out, am I adding or subtracting a number? And then it becomes really easy. So you say 8 times 2 is 16. What do I have to do to get to 15? Minus 1. Okay, 15 times 2 is 30. What do I have to do to get? Minus 1. So it's easy to see that the B is minus 1 by inspection. So I get term N is equal to, maybe we should stick with, are you happy if we stick with this method for now and we leave simultaneous? You think who prefers this method? Anyone? It's still there.
So I think I prefer this method.
Yeah, I think maybe let's stick to this method because you don't know simultaneous, and simultaneous will do later. You'll do it in core, and then you can use that easier. Let's stick to this method for now. Okay. So, and I'll do another one with you guys tomorrow. So let's say this. Okay. So I've got term N is going to be equal to 2 Tn minus 1, and term 1 is equal to 8. Okay. Right, so now the last bit we've got to do is got to find, let me check if I'm right in the answer book. What are we doing? Number 19, 20. Yeah, we're right, okay? Right, then, okay, we've got to find the value of term 15. So what do? I put the first term, 8, into my calculator. So I'm going to go 8, okay, and then I'm going to clear it. Okay, and then what I have to do to each term? I'm going to go 2, okay, times by your answer, plus 1. Okay, I've done something horribly wrong. What have I done? So I got, the first term was 8. Here you are. So 8 equals 2 times answer plus 1. Yeah, sure. Okay, it gives us 17. Okay, right. So that's term 2. Okay, which is working. It's supposed to be. Is it supposed to be 15? Minus 1. Guys, you must yell at me when I make mistakes. 2 times answer minus 1. Sorry, the formula was that. 8, sorry, 8 equals, all clear, 2 times answer minus 1 equals, thank the Lord, 15. Okay, so term 2 is 15, term 3 is 29, equals again, so it's working. Gives me term 4. Now I've got to just count. Okay, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, yep, we're right. Okay, so term 15 is equal to 114,689. Whew. Okay, it was longer than we planned. Sorry about that, guys. Any questions? Guys, if you don't have time to do the homework, it's not the end of the world. Okay, catch it up in your own time. Okay, guys, you better go. Okay. Bye if anyone's still left.
Bye.
Bye, sir.
Bye, sir.